Welcome back. In this session, I'm going to give you an overview about Spark Pool and Azure Synapse. Spark Pools gives us the ability to perform big data analytics on machine learning workloads in Azure. Synapse at the core of Spark Pool is that open-source distributed compute processing engine called Apache Spark, which is widely used in the industry for developing big data and machine learning workloads. Spark Pool is one of the many compute engines available within Azure Synapse, which offers Apache Spark as a managed service. In summary, Spark Pool offers Apache Spark within Azure Synapse as a managed service. Now let's take a look at what Spark is at a higher level. Apache Spark is a lightning-fast, unified analytics engine for big data processing and machine learning. It was originally developed at UC Berkeley in 2009, but since 2013, it's open-sourced under the Apache Software Foundation license. It's been used by internet giants such as Yahoo, eBay, and Netflix for large-scale data processing on multiple petabytes of data on clusters of thousands of nodes. Spark was built from the ground up to address the shortcomings of Hadoop. Hadoop was slow and inefficient for interactive and iterative computing jobs, and it was complex to learn and develop. On the other hand, Spark offers a much simpler, faster and easier API to develop on. Spark can be 100x faster than Hadoop for large-scale data processing by exploiting in-memory computing and other optimizations similar to most other big data compute engines. Spark runs on a distributed computing platform. Spark has a unified engine to support varying workloads. For example, it uses the single engine for streaming as well as batch workloads. It comes packaged with high-level libraries, including support for streaming data, machine learning, and graph processing. These standard libraries increase developer productivity and can be seamlessly combined to create complex workflows. Let's now take a quick look at the high-level architecture of Spark so it'll be easier when we come to discuss the capabilities added by Spark. At the center of Spark architecture is Spark Core. This contains the basic functionality of Spark. The Spark Core takes care of scheduling tasks, memory management, fault recovery, communication with storage systems, etc. It is also the home to Spark's main programming abstraction API called RDD, or the Resilient Distributed Data Set RDD, or a collection of items distributed across various compute nodes in the cluster that can be processed in parallel. Spark Core provides the space to create and manipulate these RDD collections. Early development in Spark was done using these RDD APIs, but it had its drawbacks. It was difficult to use for complex operations, and it was difficult to optimize as well. In order to optimize the workload, Spark introduced the SQL engine includes the Catalyst Optimizer, which takes care of converting a computational query to a highly efficient execution plan, and the Tungsten project, which is responsible for memory management and CPU efficiency. The higher-level abstractions such as Spark SQL and the Dataset and the Data Frame APIs makes it easier to develop applications and also benefit from the optimizations from the SQL engine. So the recommended approach to develop applications in Spark nowadays is to use the higher-level APIs rather than the RDD API. The Dataset and the Data Frame API can be invoked from any of the domain-specific languages such as Scala, Python, Java, or R. Having said that, as you sign up. On top of this, we have a set of libraries such as Spark SQL, Spark for streaming, Spark MLlib for machine learning, and also Spark Graph for graph processing. Also, Spark comes with its standalone resource manager, but you can choose other resource managers such as Yarn, Apache, Mesource, and Kubernetes. The Azure Synapse Spark Pool uses the Apache Hadoop Yarn as the resource manager. Combining all of this, Spark provides the unified platform for doing streaming batch machine learning and graph processing workloads using a single execution engine and a standard setup API. Let's now take a look at the capabilities. You can create a new Spark Pool in Azure Synapse in minutes using one Azure Portal, PowerShell, Synapse Studio, or .NET SDK. Also starting a Spark instance. One lead takes between 2 to 5 minutes. This depends on the number of nodes required for the instance. If you have fewer than 60 nodes, it takes around 2 minutes. If it's more than 60 nodes, it may take up to 5 minutes. Synapse includes a custom notebook derived from Interactive that you can use to interact with Spark Pools. The notebooks come with the capability to support data processing and visualization requirements. It's worth noting that the visualization in the notebooks are not compatible to be a tool such as Power BI. But it's good enough to visualize the data during exploration and analysis. Apart from Spark Core, the Synapse Spark Pool also comes with the addition of the open source project, Delta Lake. Delta Lake is one of the hot topics in the industry at the moment, which provides transactional capability to the data lake. Spark pools have the capability to alter scale as required. You can create the Spark pool with the minimum and the maximum number of nodes, and it'll scale depending on your workload. Spark Pool comes with a number of preloaded libraries on top of the library that already comes from Spark Core, for example. It comes with around 200 plus libraries for machine learning, data analysis, and visualization from Anaconda. Also, it has libraries such as Apache Library and Interactive Notebook, etc. Pre-installed Assistant Apps provides an ideal plugin for JetBeans Intelligence, which is useful to create and submit Spark applications to the Spark Pool. As we said before, the Spark enables us to write applications in Python, Scala, Java, and R. It supports C#, which makes it easier for Microsoft developers. Finally, adjusting apps through its better integration between its Spark Pool and serverless SQL Pool. Let's now take a look at the main use case. This first Spark Pool could be used for data preparation and data transformation workloads. It's especially useful when dealing with textual data and blob data such as images. Spark Pools comes with MLlib, a machine learning library built on top of Spark. Also, the Spark Pools in Azure Synapse comes with well over 200 libraries from Anaconda. With a combination of all of these libraries and the notebook capability, the Spark Pool provides an effective machine learning platform as well. So on this note, I am stopping over here. In the next session, we will create Spark Pool. See you in the next session.